Hello everyone. C13 NMR, that is carbon 13 isotope, nuclear magnetic resonance spectra we are studying. C13 has a nuclear spin of 1/2, which makes it nuclear active, even though its abundance is only 1.1% in nature. We have already studied these different types of spectra in my previous video. You can check them out. The first one is undecoupled spectra. The second one is broadband decoupled or proton decoupled spectra. Third one is off resonance decoupled spectra. We have done some of the examples too. The last one is selective proton decoupled spectra. Now in this technique, a specific proton resonance is identified and this is used for spin decoupling. That is, the sample is irradiated at low radio frequency pulse. And then with another second radio frequency pulse corresponding to selected protons while the normal C13 spectra is recorded. This type of irradiation causes the selected group of protons to undergo rapid transitions. Therefore, the carbon nucleus to which these protons are attached will be able to see only the average spin states of the attached protons. This results into a singlet and the splitting pattern of other carbons in the molecule is not affected. Now let us see this with an example. Now this is a butyl halide A, B, C, D. Okay, let us irradiate or let us select the C carbon. That is, this carbon is selected. Now here, if we check out in off resonance, we must get this as triplet. So C here also appears as a triplet in general. It has to appear as a triplet, but since we have selected C and we have irradiated with the second radio frequency, all CH couplings are removed. Therefore, this appears as a singlet. This is called as selective off resonance decoupled spectra. Let us see this with one more example. In off resonance spectra, this is a quartet. According to off resonance spectra, this will be a quartet, this a singlet, a doublet, a doublet, a singlet, a triplet, and a quartet. There is OCH3 here and OCH2 here. In off resonance spectra, these two may overlap. Then selective decoupling is done. That is, this one is selected frequency corresponding to OCH2. Then this spectrum gives 9 signals. 2 quartets. This spectrum thus gives 9 signals, that is 2 quartets, 1 triplet, 2 doublets and 4 singlets.